Okay, so um, we are starting a unit on polynomials, and I'm going to go through really in class tomorrow like what polynomials are. But the skills that we need to work with polynomials are exponent properties, which we already did, and we needed those to add, subtract, multiply, divide polynomials. Now we have not divided yet. That's going to be after break. So what we're doing is we also need to be able to factor. Now, when we say we've factored really x squareds and trinomials. We've done a little bit of greatest common factor. So you can see on this screen, we're going to factor polynomials, which can be x to the third, x to the fourth, x to the fifth, etc., including sums and differences of perfect cubes. We did perfect squares. We're also going to be able to factor by grouping, which is when you have 4 terms instead of 3 terms. So what I give you tomorrow is we go through this flow chart. Um, when we look at a flow chart, the first thing that we should always do is look for a greatest common factor. Now, after that, we count the number of terms in the problem, and we use the flow chart, which is really what this is saying. Meaning, do you have 2 terms? Is it a binomial? Is it a trinomial? Or does it have 4 terms? Now, we don't go anything past 4 terms in Algebra 2. So all I'm going to do today is just review the 3 things we've done. So greatest common factor, a letter or number that goes into every term in the problem. Now, with a number, you find the biggest number that goes into all those numbers. With a variable, that variable has to be in every term, and you end up with a variable taking out the lowest degree. So you can't take an x cubed out of an x, but you can take an x out of an x cubed. So when you look at this, like I'm just going to do a couple quick examples. If I say factor out the greatest common factor, first thing, is there a number that goes into 14, 4, and 2? Yes, 2. I have a y5, a y3, and a y1. They all have a y, so I can take out a y. I'm going to take out the lowest degree, which would be 1. So then when you're doing this, you either think, what do you multiply 2y to get 14y to the fifth, or you take 14y to the fifth divided by 2y. 14 divided by 2 is 7. If you take 1y away from 5y's, you have 4 left. Your signs are going to stay the same as long as you take out positives. 4 divided by 2 is 2. You took 1y away from 3y's, so you got 2y's. You got plus 2 divided by 2 is 1. You took 1y out, you have no y's left. You can always check your work by distributing. So next one. Is there a number that goes into 9 and 25? No. So you can't take a number out. You have 3 x's and 1 x. You can take out the smaller of the 2. So then, really you took out a 1x. 9 divided by 1 is 9. You took 1 away from 3, you have 2. Minus 25 divided by 1 is still 25. You took 1 away, you got none left. Now, what you're going to see is it's always going to say factor completely. Well, we've done this. I'm going to go over that in the next screen, but those are perfect squares being subtracted. When it's perfect squares being subtracted, I square root and square root. 5 and 5, 1 plus 1 minus. The directions are always going to say completely, and that's the part you really have to remember. So one more of these. 5, 15, 5. Biggest number is 5. I have 4 x's, 3 x's, 2 x's. I can take out the smaller. So if I take 5 divided by 5, I have 1. I took 2 away from 4, so I have 2 left. 15 divided by 5 is 3. That sign stays the same. I took 2 out. I have 1 left. 5 divided by 5 is 1. I took 2 out. I got none left. So again, I could distribute, make sure it is the same thing. So 2 terms. What have we done with 2 terms? The only factoring that we have done is perfect squares being subtracted. But now, how this is going to change with higher powers is it's actually going to be perfect squares. Still, I need my perfect squares like 1, 4, 9, 16, 25, 36, etc. But you don't have to just have a square. You can have any even powers. Okay, so it doesn't have to be x squared. It could be x to the 4th, x to the 6th, x to the 12th, x to the 100. So what do? I square root. Now, when you're square rooting even powers, like x squared is x and x. X to the 6 is going to be x3 and x3. X to the 100 is going to be x to the 50 and x to the 50. So it's always subtracted. They cannot be added. I always am going to have conjugates, a plus and a minus. So I notice those are perfect squares. Y minus 5, y plus 5. I square root. So again, we've done these. 25x squared minus 81. Those are perfect squares. 5x, 5x, 9 and 9, 1 plus, 1 minus. 16 and 81 are perfect squares. That's even. So it's a perfect square. I square root. 16 is 4. X4 is x2 and x2. 81 is 9. 1 plus, 1 minus. Now again, what are we going to see? We can always go farther. Sometimes we can go farther. Perfect squares being subtracted, that's perfect squares again. 2x and 2x, 3 and 3, 1 plus, 1 minus. I can't do it for plus. It would stay the same. Just for you to see one more with a higher power. 4y to the 6 minus 49. 4 and 49 are perfect squares. That's even. I square root. Square root of 4, 2. Square root of 49, 7. 1 plus, 1 minus. The square root of y to the 6 is y to the 3rd. So then the only other factoring that we have done is our factoring trinomial. So we have 3 terms. I'm not really putting an A there because we're saying, well, let's just deal with what we all should be able to do. When there's not an A, I'm always looking for 2 numbers that multiply to give me C and add or subtract to give me B. Now, is it adding or subtracting? Because this could be adding or subtracting also. If it's adding, if this is C is plus, you're adding. If C is minus, you're subtracting. And then you have your sign rules. Now, how is this going to change? This does not need to be a 2. Okay, this really is going to be even, and this power is going to be half of whatever that is. So if that's a 2, that's a 1. If this is a 4, that's going to be a 2. If this is a 6, that's going to be a 3. If this is an 8, that's going to be a 4. Okay, and you do it the same exact way. You don't think anything differently. So, this is basic x and x. 1 times 14, 2 times 7. Which ones subtract to give me 5? Because that's minus 2 and 7. Minus 7 plus 2. Larger number gets the sign of the middle. I'm going to skip that one. This one, if I look at this one, don't freak out that that's x4 and that's x2. As long as that middle one is half. Two numbers that multiply to give you 4, add or subtract to give you 3. 1 and 4. But now if this is x4, this is going to be x2 and x2. Larger number gets the sign of the middle. Again, this is where we'll talk about this tomorrow. That keeps going because that's perfect squares being subtracted. So really, when you factor completely, that's what you're going to get as your answer. Okay. That is a good start. So we'll see you tomorrow. Hopefully you watch this, do the assignment to get you started.